Hello, friends of chemistry. Martin and I are doing the review questions for Module 5. What page are they found on?
161.
161. Please read me number 1.
Can an element undergo a decomposition reaction?
Okay, so we're going to just pause for a moment and define a decomposition reaction. In order to do that, we're going to look on page, just a moment. Right at the beginning of the module, on page 134. A decomposition reaction is a reaction that changes a compound into its constituent elements. So is it possible for an element to undergo such a reaction, Martin?
No.
No, because it already is in its constituent elements, and so it can't undergo any more decomposition. Number 2, please read it, and don't read these yet.
Classify the following reactions as decomposition, formation, complete combustion, or none of these.
Okay, so we just defined what decomposition was on page 134. We said it is a reaction that changes a compound into its constituent elements. Okay, so what is a formation reaction? It's on page 137. Go ahead.
A reaction that starts with 2 or more elements and produces one compound.
And a complete combustion is
a reaction in which oxygen is added to a compound containing carbon and hydrogen, producing carbon dioxide and water.
Okay.
Or H2O.
So we're going to look at these and classify them as decomposition, formation, complete combustion, or none of these. So here we have C6H12O6 solid plus 6 oxygen, O2, in a gas form, yields to CO2 and H2O.
So that's complete combustion.
Looks like complete combustion. Okay, how about letter B? Letter B, we have 2 hydrogen plus oxygen yielding to water.
So that's a formation.
It is. It's a formation reaction. Okay. Letter C, we have NaCl solid plus AgNO3 aqueous, yielding AgCl solid plus NaNO3 aqueous.
I think that's a formation.
I think it's
decomposition. Oh yeah, none of these.
None of these, yeah. Sure, we have new compounds being formed, right?
Yeah.
But a formation reaction is a reaction that starts with 2 or more elements and produces one compound. So here we have 2 compounds and they change into 2 different compounds. So that's none of these. Okay, so it's important that we make sure we understand what our definitions are. If we don't know what they're asking us, then there's no way we're going to be able to answer it correctly. So we have to know, what is a combustion? What is a formation? What is a decomposition? Okay, in letter D, we have 2 HBr liquid plus CaOH2 solid yields 2 H2O liquid plus CaBr2 aqueous. Aqueous means it's in solution. Dissolved in water.
Okay, yes, so that's also none of these.
It is. It's none of these. Yeah, a chemical reaction is occurring. There's something going on there. It's not that no reaction has occurred, but it is not decomposition, it is not formation, and it is not complete combustion. So that's letter E. 2 NaHPO4 solid yields 2 Na solid plus 2 H2 gas plus 2 P solid plus 4 O2 gas.
Yeah, that's a decomposition.
It is. It's where we have a compound being broken down into its constituent elements. Decomposition.
Mm-hmm.
Okay. Number 3 says, which of these is not a formation reaction, right?
Mm-hmm.
So do you want to read them to me? And I'll write them out.
H2 CO3 plus 2 KOH.
Why'd you say CO3 twice?
Because
Okay. No. Plus 2
KOH yields 2 H2O plus K2CO3.
Okay, letter B.
CO2 gas plus H2O gas yields H2CO3 liquid.
C.
2S solid plus Cl2 gas plus 5F2 gas yields
5 what? F? F like Frank?
Yeah.
5F.
2 gas yields 2SF5Cl.
Is there another one?
No, that's all.
Okay, and then the question asks us?
Which is not a formation reaction.
Okay, so what is a formation reaction?
It's a reaction that yields one compound with 2 or more elements or compounds.
Yeah, look on page 137 and read what it says. Just do me the favor. Thank you so much.
A reaction that starts with 2 or more elements and produces one compound. Which means that the answer is obviously A, because the others all yield one compound, and A yields 2 compounds.
Correct. So A. Okay. It says here in the answer key, the equation for B is a formation equation because it starts with 2 reactants and makes only one in the end. Reactions do not have to start with elements in order to be formation equations. We just assume they do when we write them ourselves. Okay. Number 4. Can you read number 4?
Okay. Number 4. Which of the following is not a complete combustion reaction?
This is actually the equation, but it's okay. So what is a complete combustion equation? Let's again look it up and make sure we understand our definition. A complete combustion is a reaction in which oxygen, O2, is added to a compound that has carbon and hydrogen, producing carbon dioxide and H2O. Okay, so let's look at these. I'm not going to write them on the chalkboard. Does this in 4A, C3, 2C3H8O, does that have carbon and hydrogen?
Yeah.
Is this other one oxygen, 9O2? Yes. Does it does it yield carbon dioxide and water?
Yep.
So that is a complete combustion equation. Let's look at letter B. H2CO3 solid yields CO2 gas plus H2O. Is that a complete combustion equation?
No.
Why not?
Because oxygen is not added.
That is correct. This is more decomposition or some such, but not exactly. All right, and letter C is a complete combustion equation. Here we have carbon and hydrogen with oxygen yielding carbon dioxide and water. So the only one that is not a complete combustion equation is letter B.
Yeah.
Please read number 5.
What is the difference between complete combustion and incomplete combustion?
Let's look back at our definitions. We read that in complete combustion, oxygen is added to a compound containing carbon and hydrogen, producing carbon dioxide and H2O. This is on page 138 at the bottom. The incomplete combustion reaction, right? When a substance containing, this is on page 140, when a substance containing carbon and hydrogen burns in an environment where there's limited oxygen, one of two chemical reactions known as incomplete combustion occurs. In these reactions, carbon dioxide is not produced. Instead, either carbon monoxide or just plain carbon is produced. The amount of oxygen in the area determines which reaction occurs. Okay, so the question is, what's the difference between complete and incomplete combustion? Okay, so for this, we're going to say complete combustion produces carbon dioxide and water, CO2 and H2O. Right? Incomplete combustion produces carbon monoxide and water, or just carbon. Okay? That makes sense?
Yes.
What does number 6 ask us?
What does a catalytic converter do for an automobile?
Okay.
They reduce the amount of carbon monoxide in the automobile exhaust by converting the carbon monoxide into carbon dioxide.
That's right. So this is on page 141. The catalytic converter helps to reduce the amount of carbon monoxide by converting it into carbon dioxide. The catalytic converter helps reduce the amount of carbon monoxide in car exhaust by converting it to carbon dioxide. Okay, please read number 7.
Which has more mass, 100 hydrogen atoms, 4 sulfur atoms, or 1 lanthanum atom?
So, how can we figure that out?
Well, we find an example of how much each of those weighs.
Oh, where are we going to find an example?
Well, how about the periodic table?
Yeah, we're going to look at the periodic table. And the periodic table is going to tell us that hydrogen
is really light. It's the lightest one there.
So it's 1.01 atomic mass units, right?
Yeah. The other one was sulfur.
So we're going to multiply that by 100, and that gives us, any guesses? 101 AMU. Okay?
Okay, let's see. Where's
What's the next one? What is the other?
Well, there's. I can't. Okay, there's lanthanum. I haven't found sulfur yet, but there's lanthanum. It's 180. It's 138.9 AMU.
130.
No, that's written down as LA.
Uh-huh. And how many are there of them?
One.
One. It has 138.9.
Yes. And sulfur is 32.1, so it's going to be lanthanum. Pretty dense stuff.
Sulfur is what? 32.1?
32.1, yeah.
And there are 4 of those?
Yes. Really, I wasn't surprised. In a problem like this, it's usually the one with the least one. This doesn't even count as a trick question anymore because it happens every time.
All right, so the one with the most mass is the single lanthanum atom.
Mm-hmm.
Okay?
Yeah.
Number 8.
What do the following things have in common? 32.1 grams of sulfur, 41.1 grams of calcium, and 60.1 grams of silicon dioxide. I think the only thing I can see in common is that they all are being measured in mass.
What is sulfur's atomic
mass unit? Yeah, you're gonna want atomic mass unit.
Uh-huh.
That's the words.
What is it?
32.1.
So 32.1 grams of that is equal to what?
32.1 grams.
Watch out, please. Move your hand. Here on the bottom of page 146, read these 2 bold facts. First,
so it's 32.1 moles. An atom's mass in AMU tells you how many grams it takes to have 1 mole of those atoms.
So wait a minute. An atom's mass in AMU tells you how many grams it takes to have 1 mole. What does the next bold part say?
A molecule's mass in AMU tells you how many grams it takes to have 1 mole of those molecules.
Okay, so that's for molecules. So here we have an atom of sulfur. Is 32.1 AMU. Therefore, 32.1 grams of sulfur equals 1 mole of sulfur. How about the next example?
40.1 grams of calcium.
Well, hold on. What's the atomic weight of calcium? Please figure that out.
It's 40.1. Yeah.
40.1 AMU. That means the 40.1 grams of calcium equals 1 mole.
1 mole of their elements.
What's the next substance?
60.1 grams of silicon dioxide. So AMU of silicon, is 28.1.
And oxygen is 16.
Yes.
Ooh, look at that, 60.1. Therefore, 60.1 grams of silicon dioxide equals
1 mole.
1 mole. Pretty cool. So that's what all those things have in common. They are all equal to 1 mole of themselves.
You read the next one.
The next one, number 9, says, what is Avogadro's number? Okay, Avogadro is not avocado. Avocado's number is 1. It tells us how many pits does the avocado have. But Avogadro's number is something entirely different.
It's a mole.
Find it. What is it?
6.02 times 10 to the 23rd.
Yeah, it tells us how many. Here it is. How many atoms are in a sample of an element when that sample has the same mass in grams as the element's mass in AMU? It tells us how many molecules or atoms are in a mole? What is the number of molecules or atoms in a mole, Martin?
6.02 times 10 to the negative times 10 to the 23rd.
Not to the negative,
Yes.
right?
Yes. Hey, it's snowing.
It's snowing, yay! We're recording, thank you. Stop your simming, please, singing, not during science class. Thank you so much. Okay, number 9 is Avogadro's number is 6.02 times 10 to the 23rd, and it is the number of atoms or molecules in a mole of that substance. Why must a chemical reaction be balanced before it can be used in stoichiometry? Well, what is stoichiometry? On the top of page 156, we see stoichiometry, okay, relating the quantities of chemical substances in a chemical reaction. So if we're trying to relate the quantities of chemical substances in a chemical reaction, Martin, why is it important that we have a balanced chemical equation? You're shaking the table. Because otherwise we can't get the right answers. We won't be able to get the right relationships. If, for example, you think that there are only 3 quarters in a dollar and you have 500 quarters, you're going to get the wrong answer as to how many dollars you have.
You're not.
Because your relationships are faulty. So you need to understand the correct relationships so that you can relate one thing to another. Since stoichiometry is all about proportions, relationships, relating one thing to another, if we don't know how to balance chemical equations, we won't be able to get very far with it. So stoichiometry, that's what it's all about. That's what high school chemistry, all about stoichiometry. So live it, love it, learn it, enjoy. Is that it for the review problems for Module 5, Martini?
Yes.
All right, thank you for joining us. Let me know if you have any questions.